Alright, in this video we'll be looking at the length of vectors and things associated with that, like unit vectors and stuff. Okay, so say we take the vector -2 and 5. We'd draw an axis and think of moving -2 across, which just means 2 to the left. Then we'd go 5 up and draw this vector here. We could be interested in how long this vector is, and we symbolically write this by putting vertical bars around V. And just looking at the picture, we can see that Pythagoras will work it out for you quite easily. Okay, so you square the 2 and the 5, and add them together and square root the whole lot, and it gives you
root 29.
And of course the negative wasn't relevant at all in this calculation, because all that does is it tells you that this vector takes you in the negative x direction, which means it's going to the left. Okay, that's all the negative does, and so we don't really use that to work out lengths. Okay, so let's take a different vector v this time, say 4 and 3. I won't go through details here, but we use Pythagoras on 4 and 3, and that tells us the length is 5. Now we could ask this question here, what's a vector that points in the same direction as v, but only travels a distance of 2 units? Alright, so v travels 5 units. What if I only want one traveling 2 units? Okay, so we know what it looks like. We could draw a vector that we know is 2 units long, and spin it till it lines up with v. Okay, so I know what it looks like, but how do we work out what that vector actually is? Okay, one way we can do this is to turn v into what we call a unit vector. And a unit vector is just the name of a vector that is 1 unit long, right? And right now, v is 5 units long. And so we can make it a unit vector, which we write as v hat. See that little hat on top of v? Right, we can make it that by scaling it. Right, we saw last time that scaling is like stretching a vector, but this time, rather than stretch its length out, we want to shrink it to 1/5 of its original length. So we take 1/5 times the original vector v. Okay, so in general, you can divide a vector by its own length, or you can scale it by 1/over its length. And we get the vector that points in the same direction as the original, but only steps 1 unit in that direction. Okay, so sometimes I think of these unit vectors as exactly that, as direction vectors. Okay, and so they only take you 1 single unit step around, but what's important is the direction they take that step in. Alright, so now we've found v hat, the vector that goes 1 unit in the correct direction, that yellow one there. So we can now rescale it as long as we like, and that lets us travel as far as we like in that direction. Okay, and so if we wanted something 2 units long, we just scale it by doubling that vector. Okay, so then our answer would just be 2 v hat. So we double that vector, and we get 2/5 of 4, 3. Now, if you wanted to, you could bring the 2/5 in. You'd write it as like 8/5 and 6/5, but this will do as an answer. Okay, so that's how you find lengths of vectors. It's just Pythagoras, and how you can work with unit vectors. And we just want to think of them as vectors that point you in a certain direction you want to go, which you can then hit with a scalar to travel as far as you like in that direction. Okay, so that's all for this one. Thanks for watching, and I'll see you around.